label your notes. 7.1. We are not doing chapter 6. We are going to chapter 7. And the title of this section, and it depends on how the next couple of weeks go, but this is probably going to be one of the very, very last things that I show you how to do. So,
You're gonna say easy.
what you meant to say was, oh my gosh, that's so sad.
Did you get a eraser? No.
This is one of the last things that I'm going to show you how to do. So definitely plan on, probably not a test, but a quiz over this stuff at the end of the year. Will it be something that you have to get a 70% or higher on? I think so. That would make it a little bit more exciting, don't you think?
No.
Of course. Thank you. All right, so section 7.1, what we're going to do is find the area of a region bounded by two curves.
Oh.
Doesn't that sound fun?
No. It's a lot.
Can you condense the title?
Can you irritate me a little bit more? Don't answer that.
I'm not even trying.
Oh, man. This is what calculus is all about. Being able to find the area of obscure shapes.
What's up?
Because you guys all know how to find the. Are you crying because this is one of the last things I'm going to show you?
I need to sneeze.
There's a rule that you have to use. This is the rule. Area is equal to the integral of. I'm going to give you bound. You have to have boundaries when you're doing this. We're going to take from A to B, and you need to take the integral of. I think what we're going to do is call. I'll explain to you what all these A's and B's and R's and everything else mean here in just a second, but for right now, just write it down. Capital R of X minus lowercase r of X dx. The A of this integral stands for the lowest X value, the lowest X value of a region. What was going on there?
Not a thing. It wasn't for this class.
The lowest X value of a region. The B value up here at the top. Take a wild guess what that is.
The highest one.
You're so smart. The highest.
It's the mid.
The highest X value of a region. Capital R of X. Capital R of X. This is getting kind of messy, but hopefully you guys are able to sort through that somehow on your notes. This function right here, because it's a capital letter, we're using a capital letter just to mean that it's the largest of the two functions in the region. So label this as being the largest function. And then this smaller one, of course, is going to be the smallest. And it's just the largest in the smallest in the region that we're talking about. So if we're talking about two functions graphed, and we only want to look at them from 0 to 2, you were going to look at just exactly where, from 0 to 2, which function is higher. Is it capital R of X, or is it going to be lowercase r of X? Or is it f of X or g of X, depending on the situation. Sometimes in a region, and we will talk about this when we get there, but sometimes in one region, they'll swap. So from for half of the region, one function will be higher than another function, and the other half of the region, they kind of flip. And like I said, we will talk about one of those things in just a second. But let's jump into our first example.
What does the big A mean?
Area.
Oh yeah, I'm sorry. We're talking about area of a region bounded by two curves. I feel like I was gonna flip and you guys got upset. Is there something wrong? That's it for what I need to show you. And now we need to do some examples, of course. But that's all. That's it. Make sure that's visible because you're gonna need to use it in just a second. Ready? Are we ready for our first example? Okay, let me know when you're ready.
It's gonna be a while.
It's gonna be a while.
Like till 1:55.
All right, first example is half of x is equal to 2 minus x squared, and g of x is going to be x. And I want you guys to find the area of the region that is bounded by those two curves.
The area.
What's the problem?
You can
So
grab
we
it.
obviously need to look at what this is gonna look like graphically. We have to figure out what does this thing look like. So please have your calculators out. Use them, rely on them, love your calculators. Sometimes I will require you to draw a picture on your paper, but you certainly are allowed to use your calculator as a guide. Did someone just say something? Yeah. Okay. Yeah. Well, we're gonna figure out which one to do. Just grab a different one, because I'm recording right now, I just don't want this to take longer than it. That's okay, but just grab a different one for right now. Okay, thank you. Alright, so graph these things. Go to y equals.
Well, just
First of all, you know what, you guys, we're big kids, and probably could figure out what these things look like without having to rely on our calculators. Sometimes we will absolutely totally have to rely on our calculators, but you guys, this probably doesn't require much calculator use. So g of x is just the line x. That just means it's a diagonal line. Every point on that line has an x and a y value that match. So for example, 0, 0. You could graph 1, 1. You could graph 2, 2, etc. I'm not going to graph them all because I think you guys got the point. That is what that graph looks like. That's g of x. Now, someone just asked me, what's capital R of x and what's lowercase r of x? And I said, well, we don't know yet because we haven't graphed it. So we are going to find out in just a second. So now we need to graph 2 minus x squared. What kind of graph is that? 2 minus x squared. It's a parabola. Does that parabola open up or down? It opens down. So we need to graph right now a parabola that opens upside down. Now, if you are unsure of what this thing looks like, then, you should have it on your calculator in front of you. It is a parabola that opens down, and it is shifted up exactly 2 units. It has a y-intercept of 2. So your graph is going to sit up here, and it's going to go down. I know some of these things you guys are probably thinking, man, those were the good old days when we were looking at parabolas and stuff like that.
We're not
So the
graphic.
parabola looks roughly
It's not.
like this. Do you see the area or the region, that is bounded by those two curves?
it's a slant.
We're talking about this region right in here. All right?
That's so scary.
So we need to figure out what's the area of that thing. That's a weird shape. It's not a triangle. It's not a square. It's not a circle. It's not something nice and easy that you can just punch a bunch of stuff into your calculator. You're going to need to use calculus to figure this out. So the next thing that we need to do, if you guys remember back from this screen right here, we need to figure out what's the lowest x value of the bounded region and what's the highest x value of the bounded region. Well, we are going to have to find those by calculating that point and calculating that point. Now, don't freak out on me yet, because you have these calculators in front of you. Calculate where those points intersect, or where those graphs intersect. Yes.
That bottom one's -2, too.
This point, and you know what? We don't even care about the y value. All we want are the x values. So what did you get for it? -2 is your x value, okay? Joey just calculated that x value right there is -2. What about this x value? Is it 1? Okay. So that means that our A and B value are what?
-2, 1.
-2 and 1. The lower one, the smaller one, is the more negative, is the A value. In this case, -2, and then the B one is going to be the higher one. But I want to show you something else, because I like math, and I hope that maybe there's someone in here that still likes math. Thank you, Craig. This is what I just want to show you guys. I just want to show you how you guys should be so good at stuff like this now. What we when we came up with that -2 and that 1, what we were calculating was where these two graphs intersect each other, correct?
Yes.
So we were trying to figure out where does 2 minus x squared, where does it equal x?
Oh.
Where do they equal each other? So I'm just going to quick show you the algebra behind what happened there. I'm going to get everything to one side of the equal sign. Alright, so I'm going to move that x squared over. I'm going to move the 2 over. So on the left-hand side, I will have nothing left. I will have a 0. But when I move that negative x squared over, now I'm going to have an x squared. I still have a positive x, and when I move that 2 over, I have a -2. What am I going to do to this now? Factor it. So we're trying to figure out the values of x now that make it equal to 0. So 0 is equal to, so I'm going to just do a quick factor thing here. What two numbers multiply to give you -2, and when you add them together, they get you a +1? 2 and -1. So it's going to be x plus 2 and x minus 1. So what is x? -2 and +1. So see how easy that was? Just a quick do that up here instead of on our calculators. Yes.
Can you move the x over instead of moving everything over?
Yes, you could, but I just knew if I moved the x over, then my x squared was negative, and I can't factor it using that. You know what I mean? So I would have had to change the signs of everything anyway to make the x squared positive. Otherwise, the factoring becomes a little bit harder. So, but anyway, so we calculated a -2 and 1. Are you good there?
Yeah.
So if you want to, by all means, rely on that. If you want to use your calculators, I am totally fine with that. But you are going to have to calculate those two endpoints. So now what we need to do is this. We know we're finding the integral. To calculate the area, a is equal to the integral of. What's the a value at the bottom? -2. What's the b value at the top? 1. Now we have to figure out what. Well, I'm going to go back to this really quickly. R of x is the largest function, and all that means is the highest function. Capital R of x is the highest function from -2 to 1. Which is the highest function? F of x?
No.
F of this function right here is higher than this line. Would you agree?
Yes.
The parabola, the upside down parabola, is higher than that line. So that means that I need to call f of x, that is capital R of x. You with me there?
No.
Yes.
When you try to find the highest point, are you concerned with the little shaded area when you figure it out?
Okay. Okay.
Just the shaded region. Yep. We were only talking about right here in this section right here. See how the parabola is above the line? If you had to compare the two of them, the parabola literally sits higher than the line. So that's what we have to call capital R of x. Yes.
So, for example, if that line was above, like right over it, that would be the highest.
Yep. So this is capital R of x. This one, of course, then is lowercase r of x. So if I go back to this formula, all you have to do is subtract the functions and then integrate it. So what I need to do here is subtract the two functions. So watch what I do. Brackets first, just to kind of keep this, the functions separate from each other. Capital R of x is 2 minus x squared. Finish off your, notice I use an extra set of parentheses there. Minus lowercase r of x, which is only an x. And then, of course, you have a bracket at the end. And we are finding the integral, so we have to tack on to that dx. Dx right here. And all that means to you is that this is the derivative. You need to figure out what the formula, or what was the original function. All right, let's clean this up first of all. Actually, you know what? I gotta back up here.
Call something.
We're done. This is all that I want you to do today. We are going to practice today. I was getting ahead of myself because I know what's next. I want you guys to practice coming up with these things today. So this is all I want you to do today. Now, are they all going to be this easy? Of course not. They will be harder, and I'm going to show you a couple of examples after this too. But this is what I want you to do today. I want you to be able to come up with A and B. So in other words, you have to find the points of intersection. That's going to be, for some of you, maybe difficult. And then you have to figure out which function is larger, subtract the two, and leave it just like that. And we will work on polishing it off later. Okay? Another example. f of x equals x plus 1. G of x is equal to x squared minus 2x plus 1. Graph it on your calculators, get an idea of what this graph looks like. That f of x is just a line, it has a y-intercept of 1, so it's going to look roughly like this. X squared minus 2x plus 1, that is a parabola, it has an x-intercept of 1. So that, yeah, x minus 1 squared, very good, yep. That graph, I believe, looks roughly like this. You guys with me here?
Mhm.
Do you see the bounded region? Yeah, hopefully you do. So your bounded region is this part right in here. We need to calculate the A value and the B value, which just means we need to figure out where those graphs intersect each other. And if you want to rely on your calculator, I am going to do the algebra because I like algebra. So what I'm trying to do is figure out where does x plus 1 equal x squared minus 2x plus 1. I'm going to move the x and the 1 over. That's going to get me 0 equals x squared minus 3x. That's it. Now, these two have an x in common, so I'm going to factor an x out. It's going to leave me with x times x minus 3, which means that my two x values are 0 and 3. Do you guys agree? Is that what you got when you use those calculators, those things? Okay. So you should have gotten 0 and 3. What'd you say?
I said it in my head.
You didn't have, okay, good, good. So this value right here is 0, this value right here is 3. So when you set up your integral, the area is going to be equal to, what's the bottom value?
0.
What's the top value?
3.
It's going to be 3. Which function is higher if you were starting at 0 and ending at 3?
F.
Yeah, the line. The line is higher. You okay with that? Okay. So that function has to go first. So we are talking about the integral from x plus 1. You guys told me that one had to go first. Minus the other function, which is x squared minus 2x plus 1. Finish off your parentheses. Yes, that's it. That's all you need to do today. And honestly, never mind. Honestly, yep, that's it. I'm gonna say this stuff is not really that bad, but I'm not gonna say that. Okay, this one's a little bit harder. Not hard, just a little bit harder. All right, so two functions. The two functions are, this first one's gonna be a cubic. What do cubic graphs do, you guys?
They make an S.
Yeah, well, they kind of like, they do this. So do you see how we could potentially have a couple of bounded regions? If you can just imagine what those curves look like in your head. All right, another example. Samari, what does it say in there? F of x equals
3x cubed
okay, 3x cubed
minus x squared minus 10x.
minus 10x. All right,
X
thank you.
equals negative x squared plus 2x.
Ugh. Okay, so we need to graph that. Yeah.
Would it be easier to pull stuff out at the beginning?
To factor it at the beginning. Yeah, you know what? When you guys had to graph these things by hand, I can't remember if we had to do that at all this year or not, but you did have to do that for sure in pre-calc. Do you guys remember having to do that, finding multiplicities and figuring out, does it rise left or fall left or remember all that kind of stuff? That's what you had to do, is you had to factor. You had to factor those things first to help you find the zeros and so on. So that certainly is a way of helping you graph them, but not necessarily going to help you with the integral part of it, okay? All right, so 3x cubed minus x squared minus 10x. Go ahead, graph it, you guys. Get an idea of what it looks like on your calculator. Find at least the x-intercepts to kind of give you some direction on how this thing looks. It looks, according to what I have on my paper, it looks roughly like this. Am I right?
Yes.
looks kind of like this.
Mm-mm.
So, what is, not that you don't have to know this part of it, but what is, can anybody calculate this leftmost point?
2, probably.
Is it -2? -2, okay. This is -2, then we have another x-intercept at 0, and then we have another one over here at a +2, so we have 3 x-intercepts, -2, 0, and 2. Alright, and then we also have to graph that other ugly thing, -x² plus 2x. So if you graph that one also, you're going to have an upside down parabola. The graph is going to look roughly like this. Yeah?
Mm-hmm.
I didn't make it go far enough. That?
Yeah.
Looking like that. We need to find there's 2 bounded regions. Shade them both in. We're going to call them region A and region B. Region 1 or region 2, whatever you want to call them. The first region is over here. Do you see it?
Yeah.
Are you just saying that? And then there's another region. That other region is bounded right over here. You with me here?
No. I don't see that.
You don't see that? See this parabola? Follow it up here. It goes up and it goes back down. They intersect over here on the right. This other, the cubic one, kind of headed down here and then it curved back up again. So this region right here is kind of capped off with the parabola, and the bottom of it is that cubic function. All right. So I'm going to attempt the algebra here. I don't know how successful I'm going to be, but I'm going to try to figure out where these 2 graphs intersect each other. So where does 3x cubed minus x squared minus 10x, where does it equal -x squared plus 2x? So I'm going to move everything to this side of the equation. So we have a 3x cubed, -x squared on one side and -x squared on the other side. What happens when you have exactly the same thing on both sides of the equal sign? They cancel each other out. So I'm going to cross those things right out. I have a -10x and a +2. So when I move the +2x to the other side, I have a -12x. You guys still with me?
Wait. Oh, okay.
What can I factor out? 3x. You can factor a 3x out. So you factor a 3x out, it leaves you with x squared minus 4 equals 0. So we have to consider this. 3x could be 0. So 3x equals 0 means that x is equal to 0. And then I also have this x squared minus 4. Well, that factors to x plus 2
X minus 2. So you have
minus
plus and
2,
minus 2.
which means x is equal to -2, and it means that x is equal to 2.
Okay.
X is equal to -2. So those are our three x values. So do you see how over here on the left, which I'm going to call this region 1. I'm going to call this region over here on the right, I'm going to call it region 2. Region 1 has a different high function than region 2. Are you with me there?
Yes.
Region 1 over here on the left, what's the high function? What's the big, large one?
F of x.
That's f of x. That's the cubic function. But as soon as I get to this point right here,
G of x.
from here, for the region 2, now g of x, the parabola, is higher, okay? So we have to calculate 2 separate integrals. We have to do one integral from -2 to 0, and then we have to do another one from 0 to 2.
Mm-hmm.
So the area here is going to be, leave yourself room, okay? Because it's not that it's hard, it's just that it's long. And I, of course, I'm not very good at that. Usually I run out of room. So the area is equal to the integral of. We're going to do the left one first. So the left one goes from where to where?
0.
-2.
Oh, 0.
-2 to up to a 0. So we're going to put -2 on the bottom. We're going to put 0 on the top. You guys told me that the cubic function, which is f of x, is higher than g of x. So that means I have to put that function first. So that means I'm going to do my little bracket here. I'm going to do 3x cubed minus x squared minus 10x. Finish your parenthesis minus g of x. Well, g of x is equal to a negative x squared plus 2x. Finish off your parenthesis, finish off your bracket, dx. What do you think comes next?
The next integral.
The next integral. But what am I going to do to these things in the end?
Flip them. What is that? I don't know.
If I calculate this one that I have up here right now, that's only going to get me the area of region 1. This is region 1 right here. What am I going to do to the two of them once I get the area of
Add
region
them.
2? Are you going to add them together? So I'm just going to put a plus sign here right now. Plus, I have to do another integral, but this integral is not going to be from negative 2 to 0. It's going to be from
0 to
0
2.
to 2. So I do 0 right here. I do 2 up here. I do a bracket. It's going to be what minus what?
G of x minus x.
G of x minus f of x. So we're going to put a parenthesis, negative x squared plus 2x, finish your parenthesis, minus parenthesis 3x cubed minus x squared minus 10x, finish your parenthesis, finish your bracket, dx. That will be your integral, or your total area. Questions? Bad? Not so bad?
Not so bad.
Today you have a 12 problem assignment. The first 6 are, the graph is already drawn for you. And you just need to do the integral, which is pretty, they just give you the function, so they're not bad at all.
I was just gonna ask, you said that we don't have, are we gonna use our clock books anymore or not? Or is it just worksheets?
Today is a book assignment, but that is a good question because I have mostly worksheets lined up from now on. All right, and then I didn't finish my sentence. Oh, then the last 6, okay. The last 6 problems, 7 through 12, are going to require you to draw the graphs. And those are going to be the ones that aren't going to be as much fun. But the first 6 are relatively simple, okay? All right, okay, thanks, Mrs. Corrigan. Okay.